All right, so the next 5 problems are all out of chapter 8. The first one we have here is an elimination. I know it says substitution in the instructions, but we're going to do elimination. And remember, with elimination, you just have to pick one of the 2 variables to eliminate. I'm going to choose the x's since they're the same number. The only thing I need for them to be is one to be negative and one to be positive. So to do that, I'm going to take this first equation. I'm just going to multiply it by -1. When I do that, I'm going to get a negative 4x, and a negative 4y, and a positive 20. Now the second equation, since he's got the positive 4x, I'm just going to bring him across here. So 4x plus 3y equals negative 17. And then we're just going to add those 2 equations together. And our x's should cancel since those are the ones we wanted to eliminate, and they do. And then negative 4 plus 3y would give me negative 1y equal to 20 minus 17, which is going to give us 3. And then we're going to divide by -1 on both sides. And y is going to equal -3. So I know that I have one solution. I know that my y is -3. Now to find my x, I'm just going to pick one of the 2 equations. Honestly, doesn't matter which one. I'm going to plug in my y, find my x. I'm going to plug it into the first equation. No particular reason why, just because. So 4x plus 4 times -3 is equal to -20. So 4x minus 12 is equal to -20. So we're going to add 12 to both sides. So 4x is equal to -8. And then we're going to divide both sides by 4. And we get our final answer, x is equal to -2. So there's our x value, there's our y value. Remember, when you're writing your point, it is always x comma y. I always do it in alphabetical order is the easiest way to remember that. All right, so number 41. Again, we're going to use elimination to solve this. So we do want to eliminate one of the 2 letters. Again, I'm going to go over here with x. Honestly, it's just because it pops out at me first. I've got a -2 and a +6. I know I can make this 2 the 6 by multiplying by 3. So I'm going to multiply this whole equation by 3. When we do that, that's going to give us -6x minus 12y equal to -30. We're going to bring this guy over. So 6x plus 12y is equal to 32. Now we do have a little bit of an issue here because not only do my x's cancel, but my y's actually cancel as well, leaving me neither one of those. So that's going to be 0. But over here, -30 plus 32, that's going to leave me 2. So the numbers ended up not canceling out. And when we get something like this where my letters cancel, but my numbers do not, that is an inconsistent system. And remember, when I do inconsistent, I don't write anything here. I don't write anything here. I just circle inconsistent. That's my answer. Now, I didn't put one on here, but what I really want you guys to do is look in your 8.1 homework and make sure you understand how to solve the system that's dependent and how to write that answer independent. If you'd like me to show you one, just email me and I can look one up and do an extra video for you guys. Okay, so for 8.3, we're going to do our first just basic determinant. Remember, when we do determinants, we do our diagonals. We go across starting at the top left-hand side and multiply -30 times 23. And -30 times 23 is going to give us -690. Remember, it's always a minus here. And then we do our other diagonal, which is the 9 times 10, which is going to give us 90. Since those are both negative, we are going to add them together. And it's going to give us -780. And that is our determinant for that 2 by 2. So remember, determinants for 2 by 2s are really simple. Just doing those crosses, not too bad. Now, our determinant for our 3 by 3 is a little bit more complex. So I like to always use just this first row right here, or column. But it really honestly doesn't matter which column you use. I just like to always go with the first one. So what we're going to do is we're going to write down that first thing as a coefficient, 7. And now if I cancel out that row, excuse me, that column and that row, I see my matrix that I have left over here. So I have the matrix 6, -6, 0, 6. Then it's going to be minus. And now I'm going to use the next number in my column here, which is -10. And if I get rid of that row, excuse me, that column and that row, I see my leftover matrix there of 0, -6, 6, 6, plus, and guys, when you're doing this, it always goes back and forth between the negative and the positive, so kind of remember that. I've got my 8, whoops, sorry, still on an eraser there. So if I get rid of that column again and that last row, there's my last matrix. And I've got 0, 6, 6, 0. So now we're just going to do our determinant of all three of these little matrices and multiply them times our coefficients. So for this first one, we still have our 7. I'm going to do our parentheses and we're going to do our determinant. So we're going to do 6 times 6, which is 36, minus -6 times 0, which is 0. 2 negatives right there make that a +10. Again, doing our determinant here. Going on our first diagonal, we get 0. Minus, going on our second diagonal, we get a -36. So minus a -36. Plus 8. Again, doing our diagonal here. 0 times 0 is going to give us 0. Minus 6 times 6, which is going to give us 36. So I'm kind of lazy, and I'll admit it. I see these zeros, and I'm like, none of these zeros do anything for me. So I'm just going to cancel them out. The only thing I need to acknowledge is that double negative is really a positive. Okay, so now I'm going to multiply 7 times 36, and that is going to give us 252. Plus, we're going to do 10 times 36, which is going to give us 360. Oops. And then 8 times -36 is going to give us a negative or minus 288. And then we're just going to add that 252 plus 360 minus 288, and we get 324. And there is our determinant for a 3 by 3. So remember, they're a little bit more work because you're having to do the determinant of 3 different problems here. And like I said, I like to do the first column, but honestly, it doesn't really matter which column you use. All right, so number 44, we're going to use Kramer's rule to solve this. So the first thing I want you to do for Kramer's rule is we are going to start by doing our coefficient matrix. I like to call this the bottom matrix just because I'm more descriptive here. But it's going to be our coefficients. So 14, 3, -11, 1. And we're going to find our determinant for this guy. So again, we're going to do our diagonal here. So 14 times 1 is 14. Minus, do the other direction. 3 times -11 is a -33. So we really have 14 plus 33. And 14 plus 3 is going to be 47. Now remember, this isn't my answer. This is just the bottom of my x and y when I go to find them. So let's start off with x. So the bottom of my fraction here is going to be 47. I know that that's my bottom matrix. And what we're going to do our top matrix is, remember when we listed this out, our x's were in the first column, our y's were in the second column. So we're going to replace our x's with our answers up here. So we're going to have -37, -18, and then we're going to leave our y column completely alone, -11, 1. And again, we're going to find the determinant of our top. So we're going to start by doing that diagonal. We get negative 37 minus, we do our other diagonal, which is negative 18 times negative 11. That's going to be a positive 198. When we add those together, that's going to give us negative 235 over 47. And when we do that division, we get negative 5. So again, we know this is going to be one solution. We know our x value is going to be negative 5. So now we're going to find our y value, doing the same thing, except this time, when we do our top matrix, we're going to replace the negative 11 and the 1, the y column, with our answers. So I'm going to go ahead and do that. Negative 37 over 18, and then 14 and 3 are going to stay the same. Again, doing our determinant here, we're going to do 14 times 18, which is going to give us a negative. Oops, you know what? I dropped my sign there for a second. There we go. 14 times negative 18, which is going to give us a negative 252. Minus, then we do our other side, 3 times negative 37. That's going to give us a negative 111 over 47. 2 negatives in a row again. There's our 2 negatives in a row. It's going to make that positive. So when we do negative 252 plus 111, that's going to give us a negative 141 over 47. And when we do that division, we are going to get negative 3. So there's our answer for that one, negative 5, negative 3. The biggest thing when you're doing these is to remember that here for your x, we replace the x column with the answers. And then here for the y, we replace the y column with the answers. And other than that, you're just finding those determinants for the 2x2s. Okay, so the very last problem is probably one of the most time-consuming ones in my opinion, and that is doing the Cramer's rule for a 3x3. I also want you to notice you've got some blank spaces here in this problem as you look at this, and that's because we're missing some variables. So when we're doing this, we do need to add in all these missing. So we need to say plus 0z plus 0x, or I don't really need the plus in front, I need it behind, but that's okay. So 0x plus y, and then plus 0y. So remember when we're doing these, we always want to have, I always want to have all of the variables there, and so if they're not there, we add in the zeros. So again, we're going to do that coefficient matrix, which is going to be the bottom of our fraction when we find our x. So we've got 1, 0, 2, 24, 1, 0, and 0, 17, 21. And we're going to find our determinant of this. Again, I'm going to use this first row as my kind of row on as I go through this. So I've got 1 to do my determinant here. Remember, I'm going to cancel out this row, or that column in that row. So my leftover is my matrix I have. So 1, 17, 0, 21 minus. And then we're going to do the same thing with our 0. So we have 0. Again, I'm going to take away this column and that second row. So my matrix for this one would be 24, 0, 0, 21. And then for the last one we do here with our 2, we have plus 2. Again, taking away that column and the last row, we get 24, 0, 1, 17. Okay. So we still have 1, parentheses, doing our determinant here, we have 1 times 21, which is 21, minus 0 times 17, which is 0, minus, now I'm going to be completely lazy on this. Since we are multiplying by 0, I don't really care what's going on here because I'm going to multiply by 0 anyway, and that's going to give me 0. Plus 2 times, again, doing my diagonal here, I've got 24 times 17, and 24 times 17 is 408, minus 1 times 0, which is 0. So this is going to be 21 plus 816, and the bottom of our x for our Cramer's rule is going to be 837. So now to find our x, remember if I come back up here to my matrix, this guy right here is my x column, so I'm going to replace that with the answers. So remember our answers are up there, right over here. So we're going to have negative 20, 84, and 113. So in my matrix here, negative 20, 84, 113, and the rest of the columns are going to stay the same, 24, 1, 0, 0, 17, 21, over 837. And we're going to bring that 837 back in just a second. We're going to focus here on the top and just trying to figure out what the determinant of this new matrix is. Again, I'm still going to do the same thing. I'm going to use this first column as my kind of pivot row, or however we're going to call that. I'm going to do negative 20. If I take away that first column, that first row, I get that matrix 1, 17, 0, 21, minus, so now I do the same thing with the second one here. I've got 84. So I'm going to still taking away the first column. Now we're taking away the second row. So this is going to give us 24, 0, 0, 21, plus, and now we're doing the last one with the 113. So we've got 113. This is still taking away that first column. Now the bottom row. And we get the matrix 24, 1, 0, 17. All right. So now we're still working on the top here. So we've got negative 20 times. When we do our determinant, we get 21 minus 0. Then we have minus 84. Again, doing our determinant, we got 24 times 21, which is 504, minus 0 times 0, which is still 0, plus 113. And we're going to do our 24 times 17 again, which is 408. And our other one, 1 times 0, which is minus 0. And again, all of these minus zeros we don't really care about. They're not adding or subtracting anything from our number in the inside. So now we just need to do these multiplications. So we've got negative 20 times 21. That's going to give us negative 420. We have negative 84 times 504. That is going to give us negative 42,336. Plus 113 times 408 is going to give us 46,104. We're going to combine all of that or add all that together, and that is going to give us 3,348. And then we're going to bring back our denominator here of 837. And that is going to divide out and give us a value of 4. So now we know, remember this is my x value, so my x is equal to 4. So if I come back up here, I know I'm going to be one solution. I now know my x is 4. Now, you can do this same procedure to find the y and the z that we just did, or if I go back up here and look at my original problem without that 0z, I notice I have x plus 24y equals negative 20. So I have an x and a y and an answer. I know what x is now, so I can just substitute it in and say, okay, so 4 plus 24y equals negative 20. So to solve this, I'm going to subtract 4 from both sides. So 24y equals negative 24. I'm going to divide by 24 on both sides. And y is equal to negative 1. Oops, forgot my negative there. So they got this answer now. This is negative 1. Well, if I know what y is, if I look at that second equation, the second equation on my chart here is y plus 17z is equal to 84. Well, now I know that my y is negative 1, so substitute it in. Negative 1 plus 17z is equal to 84, so I can add the 1. So 17z is equal to 85. And divide by 17 on both sides. And we get that z is equal to 5. And that's our last answer. If I come back up here, I got my last point, 5. So now I know what x is, I know what y is, and I know what z is, and I only had to do the Cramer's rule to find the x. And by the way, I used it to find the x first. It doesn't really matter if you find the x, the y, or the z first. I just kind of always gravitate towards finding x first. But there's no wrong way to do this particular problem. Like I said, you can even continue doing the Cramer's rule to find the y and the z, just like we did for the x. It's up to you on how you want to do that. If you have any questions about the review, just let me know, and I'll try to get back to you as soon as possible.